All right. Well, thank you. Thank you, everybody, for coming. My name is Ragi Burhum, and I'm the co-founder of Amigo Cloud. Amigo Cloud is basically a service where we let cities and fire stations, disaster responders, normal people, universities upload their geographic data to our cloud. Then once the data is on our cloud, we push it into a whole bunch of phones. We let them style it, edit it, work offline, search. And then whenever there's internet back, we basically synchronize it back and connect with all these GIS enterprise systems. My co-founder and I have been working on GIS problems for the past decade. So we've run into a few issues that I actually wanted to share with you, and this is what this is based on. So if you ever try to build a real-time tracking solution, what you'll notice is that the very first problem that you stumble upon is not an actual technical problem. It's going to be a licensing problem. And so I don't know if you do this, but I do that with every single mapping service that I use. I actually read the terms of service, and they're really, really long. But if you do this, and in the context of trying to build a real-time tracking solution, you realize that you're not allowed to do that, right? Like if you're trying to put your maps behind a password-protected site, or if you're trying to do some sort of a fleet tracking or display things in real time, you'll realize that the providers don't want you to do that. And the reason they don't want you to do that is because there's an entire huge business around this, right? Usually the data underlying the maps is owned by big companies like Teleatlas or like I guess TomTom now, Navtech or even Google, right? And there's an entire business infrastructure made upon selling fleet tracking things and just value-added stuff. So anyways, I don't want to turn this into a licensing talk. That's actually a whole full hour that would probably bore everybody to death. But let's move on, right? So when I see a map, most people actually look at this, right? But I don't see this. What I look at is this, right? This is sort of the underlying structure that generates that other image. It's vector data, raster data that you're combining in order to be able to generate a final map image. If you look at it closer, you'll realize that it's just a whole set of nodes and edges that form polygons. Some of the nodes represent points of interest. Other ones, when combined, represent parks, whatever. And so it turns out that depending on the type of problem that you're trying to solve, sometimes the structure of these underlying vectors is important, right? So if you're trying to do things like navigation, you want to make sure that the edges have information about speed, information about turn restrictions, information about direction. But if all you're trying to do is show a base map that just gives you really good context of whatever it is that you're trying to draw on top of your base map, right? It's a base map, right? It's not the actual data. Then there's a whole bunch of free data sets that are really good for that. So I'm just going to run over a few. I don't know if you know them, but after this you will. The first one, when we talk about free data sets, the one that always comes up is OpenStreetMap. OpenStreetMap, so most people when they look at OpenStreetMap and they think about it, it's because they type openstreetmap.org, they went to the website, they look at this tile that is not, it's questionably styled. But that's not the beauty of OpenStreetMap, right? The beauty of OpenStreetMap is that it's a wiki. And so you can edit it, you can extract all the underlying vector data, and it comes with a pretty decently liberal sort of license, right? It's Creative Commons, so actually database commons. It's a new license, open database license. So you're supposed to, there's a few things that you have to do if you use it, but for most use cases it's good enough, and you can basically do whatever you want with it. So another data set that most people are not too familiar with is NAPE, right? The United States Department of Agriculture publishes, satellite imagery for basically the entire U.S. And it's at a really nice resolution, enough to use on base maps, depending on the scale that you're using. But it's just right there. You can go download it and use it, and it's free, right? Versus the GeoI imagery that would probably cost you, thousands and thousands of dollars, hundreds of thousands of dollars. Other data sets that are available out there, like SRTM, a lot of people that do anything with elevation, they know about this, right? There's usually 90-meter pixels. There's variations of it, depending if they went through labs in Japan or other places. But the whole idea is that you can get a worldwide sort of elevation data set that you can do. You can do a lot of 3D things. You can do some analysis. It's really interesting. I think this image is from Mount Everest. Another data set that is really popular nowadays is natural Earth data. It basically contains a whole bunch of population information, political boundaries, important cities, and so it just makes for a really low noise base map that allows you to just give minor context, but it doesn't get in the way for zoomed out scales. I recommend you to go in there and look it up. There's a whole bunch of vector and raster data that is associated with it. But at the end, the whole point is that there's a whole bunch of free open data out there. Sometimes it's difficult to collect it. I mean, it's probably one of the most difficult things that we do in GIS. But if you know where to look, what you'll realize is that you can grab that raw data, combine it with a style file. So what's a style file? There are map renderers out there. The 3 most popular map renderers, open source, free, are MapNIC, MapServer, GeoServer. So they all have their own styling language, but the concept is that you can grab this raw data that you collected from different places, combine it with a style file, and produce some really nice cartographic output, right? If you don't like parks, you can just omit them. You don't render them. If you want only the major, highways or whatever, just render those. If you want them to be green, you make them green. So there's a lot of different ways that you can manipulate the data and basically make it look the way that you want it to look. Once you have that, what you can do is you're going to want to have a way to look at it in the browser, right? You want to have a way so you can have JavaScript application that you can zoom in, zoom out, and be able to show the different tiles. These are 2 of the popular JavaScript mapping libraries that give you, that sort of slippy map type of feel. OpenLayers is a little bit heavier, has a lot more functionality. Leaflet just usually goes for minimal things. It's small, it's fast, it uses all the CSS3 transitions. So you gotta sort of pick the one that is best for the job. So, when you have all these things, right, you usually end up, this is what I would call a traditional geostack, what it looks like, right? You have some web client on one end that, it's using OpenLayers, Leaflet, one of those mobile JavaScript libraries. And, it does a request. And in this case, I'm putting Varnish. I'll explain later why I'm putting Varnish in front. But, you go to your standard web server. I chose just this, Nginx, could have been Apache, could have been whatever else that you like. And in this example, I'm using, Django, right? TileStash, I'm going to touch upon. Memcache, just for caching objects. And MapNIC. So MapNIC is one of these map renderers that I talked about, right? And so usually all your data that you collected, if it's vector data, it'll mostly go into Postgres, PostGIS. That's just what people use nowadays. But if it's a lot of satellite data, it's still questionable whether, you can put it in PostGIS, but it's still questionable whether that's what you want to do. You probably want to keep it in external drives and just refer to them, right? The reason for Varnish in this presentation, I'm going to go on further actually on it, is that a lot of rendering these styles takes a lot of time. And so depending on the amount of data that you're rendering, you want to add some some sort of caching. But the second reason that we have varnish here is that it also can act as a reverse proxy, and I'll show you why this is useful. Tile cache. So tile cache, right? Tile cache is this sort of tile manager, right? I go to tile cache and I say, I'm sorry, tile stash. I go to tile stash, is this manager. So I ask it for a tile. And tile stash, what it does is basically looks in different places. And if it doesn't find it, it goes to Mapnik and says, please, this is the style that I have. Render, giving me an image that represents the XY location that I'm asking for. And so how difficult is it to integrate in something like Django, right? It's like really, really easy. This is actually all the code that you need to do that. If you're familiar with Django, you'll realize that this is just a class-based view, and this basically what I did is I have a urls.py that is mapping to this URL. This is what the view looks like that actually consumes it. So if you look, there's the profile, the standard Django profile has been extended to include a tile config file, which has the tile stash configuration. And then I just pass it to the normal tile stash API saying, hey, listen, this is the configuration, what's the XY. For this zoom level, what's the tile at X and Y, and it just gives me back an image, right? And it does a lot of fancy things to do that, right? This is one example. One of the things that it does is just by adding this tiny little bit of code on tile stash, basically you can tell it that, first look in memcache, then look in file disk, then go and render in Mapnik, and then store it back in those things. So you can get some sort of like multi-tier caching. It becomes really useful when you start doing a whole bunch of tiles for the entire world, right? So knowing these things, knowing that there's tile stash, there's Mapnik, there's Postgres, there's PostGIS, there's all these other things, you may think like, oh, I can now I can build a real-time tracking application. I have all the components that I need. And so it's easy to fall into that, right? Where you're thinking like, oh yeah, this is all what I need. The truth is that to build a good real-time tracking solution, you need a stateful connection, right? The stack that I showed before shows what I would consider more of a traditional stateless sort of architecture. And this is actually something that can piss some people off, but it is. And so you can have actually a long conversation on what is really a stateful connection, what is really a stateless connection. Are cookies turning traditional HTTP into stateful? It's questionable, right? But the issue still remains. When you have an architecture like the one before, you're basically, every time that you need to figure out new state from the database, you're doing a get, right? So what you end up doing is a lot of implementations end up just polling. And like, if there's one thing that you're going to remember today is that polling for real-time tracking is really, really, really bad. Like really bad. The reason is that it's like, if you really sit down and think about it, it's stupid, right? Like, you have 1,000 vehicles that you're tracking. And so people usually choose granularity. Let's say that you choose like 1 second granularity, that you want to know where things are. You don't want to go and like, have 1,000 vehicles just polling your server every second. Has something changed? Has something changed? Has something changed? You don't want to do that, right? What you actually want to do, is have the server tell you that something changed, right? Imagine if, I don't know, chat rooms were implemented like that, where like, you're constantly asking everybody if they've replied to your message, right? It's just bad. So server-side events. If the server was able to tell me, hey, maybe only 10 of the cars from the 1,000 cars that I'm tracking have moved, that would extremely reduce the amount of messages that are going back and forth. And so that's what I want to do. So, thinking about it, okay, well, what it boils down to is like you could be using WebSockets, right? WebSockets are here, and they're this like 1970s technology that we had back in the day, 1980s actually, technology that we had back in the day. It's just like now it's available, it's on the browser, right? And the support is good. It's not like it was even a couple of years ago. And we have libraries like Socket.io that allow you to have fallbacks if the support is not fully there. So it's like, why not use it? Going back, so if you go back to your original computer science classes, you'll remember, this is a classic thing that always comes up, right? A pub sub queue. Right? You have a queue. A lot of people push messages into the queue. There's a publisher. There's people that are sending messages, and there are processes that are, subscribing to particular channels and listening for the messages, right? And so, if you look at the Python ecosystem, you realize that there's tons of implementations of the same thing, right? RabbitMQ has a pub/sub in there that's supported by Python. Redis does too, and so why not use it, right? We'll go back and talk about how it fits with this proposed architecture. For those of you that have not used something like Celery, right? Celery is super awesome. It's basically this semi-data queue abstraction layer, actually. It's this semi-queue abstraction layer that allows you to, put different queuing systems, and you can set it up with Redis, you can set it up with RabbitMQ, and it's the same API that you use. It allows you to do a lot of asynchronous processing, right? So simply, like, let's say that I defined a method called doWork on a class. Then I can just put this Celery decorators around that class. And what it allows me to do is basically, it adds this delay method. So if I make the call using doWork, the whole thing is going to be synchronous. It's going to block until everything gets processed. But if I call delay, then the entire work gets like put into a queue, and it'll be processed by the Celery daemon. And so if you think about it, there's tons of things that you want it to work that way, right? Like if you're adding somebody to, using the MailChimp API, and you want to add them up as soon as they sign up. Like, why would you do it synchronously, right? Like, there's something that you just want to throw in a queue, and like if it fails, you want to retry. You don't want to do it all throughout the same request-response cycle. So the same thing applies to processing of geographic objects, right? A lot of the times when we're doing things like looking at vehicles and tracking them where they are, you're using this concept of geofences. So you want to know when the car is entering a particular polygon. You want to know when the car is leaving a particular polygon. And so do you want to calculate that exactly when you're telling the server that you are updating the vehicle, or do you want to do it outside that request response and maybe with a second delay and then notify everybody that this happened? Second one is the right answer, by the way. So if we take the original sort of stateless stack, traditional geostack that we talk about, and we slightly modify it, we can end up with something that looks kind of like this. This is just a proposed solution. There are actually many different combinations of how you can rearrange this, right? If you look starting from the left side, you'll see that besides, in the client, besides the regular open layer stuff that we had before, now we have Socket.io, right? Socket.io, again, gives me this abstraction. If WebSockets are available, I'm going to use WebSockets. If they're not available, it falls back to Flash. If that's not available, I fall back to long polling. You don't want to do that, hopefully, but it can do that. And so now you'll see there's a difference in between the lines. And you'll see that, I guess I didn't explain what the arrows meant, right? So the arrow is basically what is the node that is, who is starting the request. So in this case, you always have the client starting the request with the black nodes, with the black lines, but now with the blue lines, which is the path through WebSockets, now it's bidirectional, right? The events can come in from the server out, or it can go into a server through the same thing. So that's why I had, if you look at Varnish, that's also why I had Varnish in there. Not because it's doing the HTTP caching, which is really good that it does that, but because it can also add it can act as a reverse proxy, right? So you can basically configure with little small lines of code, and you can say, hey, Varnish, if WebSocket traffic is coming in, send it to this server. If regular traffic is coming in, send it to this other server. And so in that case, what you see is that I added this sort of Node.js server on the top. That Node server is really like 20 lines of code. It doesn't do anything. It's really just a dumb HTTP, like WebSocket proxy. That's really what it's doing. In reality, I like Django, right? So I already know how to use it. I don't want to learn a new language. I want to reuse all the components that I normally use. So what I do is, like, whenever that I need authentication, whenever that I need to do any processing, like use the ORM, the templates, all the stuff that I normally use, if there's any of that needs to happen on that node side, I just do get and post requests to my regular Django app at the bottom, and it just works, right? But I get this non-blocking server push functionality now, so I can actually start publishing messages back out. And so if you look at the bottom of the graph, you'll see that there's a Celery with RabbitMQ. So the way that this works is that RabbitMQ creates, outside of Celery, you can actually make RabbitMQ create one of these pub/sub channels. Node is listening to that channel in RabbitMQ. Whenever that I need to generate an event and publish it out to all the cars or whatever, all I have to do is just publish a channel into publish a message into the channel, and then Node it's listening, so it receives the message and can push it back out through WebSockets. So what this allows me to do is basically any single time that a new car, a new vehicle, new person, whatever that you're tracking, I don't know, I'm not judgmental. Anytime you have one of these things, then Node can basically forward the processing of the geo objects all the way down through the regular pipeline. And whenever that they're done, then everybody else can, if there's a message like 2 objects have entered an area they're not supposed to be, then Celery will go and publish the message, and Node will receive it and forward it to whoever is that it's supposed to get that message. If you actually think about it, it's not just for real-time objects, right? Like this could be used for a whole bunch of other things too. In the morning, when I was looking at these slides, I realized that it would be really good if I could set up a demo. So I wrote a really bad demo this morning. I don't know how buggy it is, but if anybody has a phone, anybody wants to go look at it, you can basically go to abuse.amigocloud.com. The reason why it's called abuse is because I didn't intentionally optimize it. So instead of, normally, like if you're tracking movement, you send one point, you send another point, you interpolate between them on the client so you don't have to send all the messages. Here, what I do is, I'm going to put my name so you know it's me. So you got this guy, we got this guy, okay. You guys can start moving. There you go. So what this is doing is every time I do this, just my own message, right? I'm generating like 100 messages because I'm sending every single XY. This would like completely destroy your servers, right? But what's going on is like, wow, okay. Okay. So, but what's going on is that if I need to do a whole bunch of writes, there's a lot of messages pumping through this thing. If I could actually just show you the amount of messages, like this, a lot of messages being pumped through, okay? And so the thing is that these are being queued up on Celery, right? They're not going to affect my web server. They may delay a little bit when it's writing, but if I need to actually scale that, what I can do is there are ways to scaling Rabbit. There are known ways to scaling Celery. So, yeah, I think that's all I got. So
We have a microphone set up.
questions?
If you have any questions.
Wait, one does not simply add markers. Forgot about that.
Hey, I'm just curious if you've messed with G-Event Socket.io at all, and if
Yeah,
you've noticed any performance difference between Node.js and Socket.io.
I did.
Sorry, Geo.
But this was a long time ago, right? I tried it. We were building this about a year ago. So when I tried it, we did do performance tests. The thing with Node, and I may get some hate for this, but the thing with Node is that everything from the top, going up is built asynchronously. And really, like, I'm only doing 20 lines in there, right? Like, I can post the code. It's really 20 lines of code. It doesn't do much. All this stuff is really being done in Celery and Rabbit and in my standard, Django application. So all the samples that I found, they were Node, so it was really easy to set up, and I have not regretted it, actually. Yeah, it's a lot of things being pumped in. Any other questions?